All right. Well, we're all here tonight to talk a little bit about Python testing frameworks. The senior test engineers, automation engineers are already in here. I hope you guys can get something out of this because I picked too many tools to go over for the time slot we have, and I'd like to do deeper dive onto some of this stuff than we have the time for. But if you have specific questions or you just want to kind of chat about stuff, stick around afterwards. I'd be happy to do that. A couple things up front real quick. We do have opportunities here at Science Logic right now. We have some open positions. In the back end where Jeremy works, we're all Python, but we do have some PHP positions on the front side if that's in your skill set as well. There's a list of our current openings right here. I'll drop it on this chair by the door. If anyone is interested, just go ahead and pick one up on your way out. And if anyone else in the room is working at a company that's hiring, please, go ahead and stand up and you can, say something about your company as well. No takers. All right. Sounds good. All right. So tonight we're going to go through these four tools: Nose, Lettuce, Robot, and Multi-Mechanize. I kind of picked these tools because I thought it gave a good overview of what's possible in Python throughout the different layers of that where you want to actually run your tests. So let's just start off with Nose. Nose is a unit test extension. But what is a unit test? I know I've had a lot of discussions in my career, friendly debates about what exactly is a unit test. I can tell you, ideally, it's a code level test. It's automated, has a narrow scope, minimal dependencies. The execution order does not matter. So you wouldn't want to depend on one unit test being executed before another. And yeah, there's some discussion about where unit testing ends and integration, smoke, simulation testing begins. But I think we can all agree that unit tests should be executed directly from the source tree, or at least have that ability. And the reason is because that will support a continuous integration environment. So when you can execute your unit test manually, of course, right? You can go into your working tree and run Nose tests, and they'll just run before you commit your code. But we could also integrate that into a system that will tell us which commit broke the build. So we can see a green light going down the line, and as soon as we hit a red light, we know that it was this commit and which developer it was that broke the build, because now unit tests are failing. And I'll give you a little taste of that. Go ahead.
Is this like repository neutral, like Mercurial versus?
Yes. There are lots of continuous integration tools out there. The most popular, at least the ones that I have the most experience with, are Hudson and Jenkins. Jenkins is, they both say that they forked each other, I guess. They're owned by Oracle. And Jenkins really is the open source one that the entire development team has moved on to. But yeah, you can interface Mercurial, SVN, or Git. We have a Jenkins instance just for our test automation group that's actually interfacing with both Git and SVN for different projects. So to install Nose, if you guys are unfamiliar with installing Nose, you pip install Nose. In fact, I think that after I finish this up, I realized that every single package that we're going to go through tonight is pip installed. So hopefully you guys are familiar with pip. All right, so a couple pieces about Nose. Existing unit test classes are compatible with Nose. So if you have already written unit test classes, you can just execute Nose from your source tree, and Nose's test discovery will be able to run them as long as they're named in a certain kind of naming convention. And if you're just going to have a free-floating function, you want to start it with underscore test. But if you're going to run a class, you want to start it with capital T test. And then that will be an indicator that Nose's discovery should look into this and potentially run your unit test for you. Now these are very simple, right? We're not doing anything complicated here. We're just doing some simple assertions that are definitely going to be true. But this is what it looks like on the command line when you run it. Nose test. So I haven't told it where to go. I'm just in a working directory, and it goes out and finds these two tests and runs them. I slapped that -v onto so we could see which tests are being run. But we ran them very quickly, which is one of the biggest positives about unit testing is how fast they run. So going beyond a simple example, there might be reasons that we want to do things before we actually run the unit test. We can't just, we don't want to necessarily bake that into the unit test either. We want to know if the setup failed or what we're testing failed. We don't necessarily want to link them.
Like loading a temporary database with some sample data.
Precisely. So if you need to, or a mock object, this might be where you create your mock object, for your unit test. But yeah, loading a test database, a MySQL database, with some test data that you're going to run against would be appropriate for that setup. And this is how you manage that problem of having unordered tests. If you really need to have a certain scenario to actually run your test, your instinct may be to run that test earlier on, and then get to it later. Get to your actual test. The scenario you were talking about now later on the test. But that's a bad idea, because if it breaks the entire chain of events, and all you know is the first failure is failing. You don't know what else you're not seeing because all the rest of your tests depend upon it. You can manage that problem with setup methods. So we can set up our database instance here, and we can tear down our database instance there. So yeah, I have some of that actually listed in here just as comments. I'm doing something very simple here, just so it would fit on one screen. In my setup, I'm just opening a file and I'm writing, a string to show you that we've executed that section. Same thing in the teardown, and I have two test cases, test case 1 and 2. And so when we execute this, we should be able to look at the output and determine, and give us a good idea of the ordering. So we can see that I still have unordered execution. I just ran the 4 tests, and if I cap the file, I can see the setup ran, test case 1, teardown runs, the same setup runs again, test case 2, the same teardown. And that's for one particular test in one particular module maybe. You don't have to have the same setups everywhere. You can create a library that will allow you to create your mock objects or load your database. Maybe you can do a similar type of thing multiple places. You can instantiate something so you can make it modular. You can use the same method, the same library method among many test cases to do that. Do you have a question?
Yeah, I might have missed something in the beginning, but beside the fact that nose is compatible with unit tests, so if you have unit tests and you want to switch to nose, it's easier. What are the other advantages of nose beyond unit tests and beyond the other test programs that you're talking about?
I'll certainly talk about that. Now, unit tests really are a developer responsibility. So us QA engineers are not really responsible for writing these tests. These are to help developers out as they're going through the code. There's different ways of doing it. There's test-driven development where you write the unit test first, and then you go and write the code that'll make it pass second. Or you can go back in and maybe create a scenario, a test setup for legacy code, but it really is a developer responsibility. QA engineers aren't expected to do this, but it's good to know about it. It's good to understand how it works, because as QA engineers, you get more in automation, you really do become a developer. You're just developing on a different project than the company you're working for is. We have 54 unit tests that I execute just for my automation suite that have nothing to do with our actual product EM7. And I'll describe some of why I need those tests as I get a little bit farther in here.
Brandon, I think what's missing is what's the purpose of nose?
Oh, the nose is a test discovery engine, really, right? So you run the nose tests in the top level of a directory, and you want to say, go look at all the Python modules underneath of this directory tree, and if anything matches my pattern, right, that test underscore pattern for the file, then look into it for unit tests to run, and if you find them, run them. And the nice thing about that is that when I go as a developer, write a new unit test, I don't have to find some file, some test execution machinery where I need to go enter, okay, now run my new unit test. I can just dump a unit test into my module, maybe right in my code, or right next to my code as its own unit test file, and Nose will automatically discover it.
Right. So versus unit tests where you have to write a top-level routine
right.
that goes and lists all the unit tests.
You have to explicitly run them, suite. And Nose will implicitly run any tests,
okay,
right?
So
based on a naming convention.
That's the only advantage of it, the test discovery?
They'll probably get
That's the main advantage. That's the main advantage. Okay. I could say that Nose parameterized fixes a lot of problems with Nose and makes it much more powerful. And it's a little project. It's a very small module written by David Willever, but it allows for data driving these unit tests. And what a data driving a test means is that we have one unit test that we want to execute multiple times with different sets of input. And so this is a David's quote here. Nose has test generators, but they kind of suck because they make it difficult to separate the data from the test. They don't work with subclasses of unit test.testCase, which is a big one, and they often require a second function to do it. So let me show you a little really quick unit test that is written with nose parameterized and the difference. So what we do here is, we have some imports, and this is our parameterized data. This is our test data, and what we're testing is a simple function that calculates the power of of an integer. And so we provide it, the base, the exponent, and then the expected result. And it's this one function, but we've wrapped it in this nice parameterized decorator that will input all these different sets of data through it and make sure they all work. So, with regular nose, you may need 4 separate methods to test these 4 separate sets of input. We can do the same thing down here if we subclass unittest.testCase. We use parameterized.expand. This .expand is what allows you to subclass testCase, which nose doesn't normally allow. And we have some extra inputs, and we're testing the floor here, the circuit there equal. So we can run it the same way. It's just nose test -v. You don't have to change the way you execute them, and it runs all your tests. And we can see that even though we only have 2 unit tests, we ran 7 tests. And it's because of this parameterized data-driven input. So I have a very specific problem to my role here at Science Logic. One of the things that I'm tasked with doing is testing our web services interface, which I'll probably call the API the rest of the time. And one of the things that I need to do is I need to write my tests in a way that I abstract the transport and coding. So I need to be able to do it in JSON and XML. And I don't want to have a whole suite of JSON tests and a whole suite of XML tests. I want to have one common object type that a payload type that I can export into JSON or XML. And the way that I'm doing that is with a library called XML to dict. It's my common object is a dictionary type. And the way that I do it, it's kind of ugly. It's really ugly, but it works really well, and it's not that long. But when I go in, I find a new area of the API that I want to look at. Oops, jumped ahead. When I find a new area of the API that I want to look at, I might need to modify my machinery. And as I modify it, I have the potential of breaking something that used to work as I touch this complicated, kind of uglier function. So let me show you real quick, because I know we're already running late. Actually, here we go. Okay, so real quick, this is something clever, and I hopefully won't dive in too deep here. So what I do is I have a function called getList, and all it does is it uses a glob, which is like a way to basically do pattern matching on the file system and pull files out. And I grab all the JSON and XML tests. JSON and XML files. These are representations of our API resources, and I do some stuff in them. And I basically make a JSON only and an XML only set. Warn myself if I don't have a pair of each, right? So I want to take a JSON version of an API resource and an XML version of an API resource, and I have them in this unit test directory. And I'm going to do some operations on them to make sure that my encoder encodes and decodes them correctly. So these 2 representations match. So first off, I do some quick warning if I'm missing a file, essentially. And then down here is where I actually use nose parameterized to run these tests. So I parameterize expand tests, which I do that glob work to grab them out, and I dump them into this method. And all it does really is, this is my piece of software here that I'm testing. I'm testing the decode of XML and JSON, and down here I assert that the JSON decode and the XML decode are identical. And if they don't, then I do some additional stuff to help me out, find out what actually went wrong. And then there's one more down here, which is pretty much the same thing. I'll just skip over it, but what it really does is it takes the XML version, puts it into my common object type, and then back into XML, and asserts the 2 XML versions are equal to each other. So to run this, when I decide I need a new area of the API that I want to test, all I have to do is curl, basically go out and do like a command line grab of that API resource and save it to disk in a particular directory, and from now on it gets executed. So that one command, just grabbing that resource, just putting the directory, its presence alone is enough to make sure it gets run. So that was my entire method. Those 2 functions were the only unit tests I have, but I've run 54 tests. I look at all these different areas of the API that I have, device, ticket assets, appliance. Some of these are really complicated web service resources, and they've all, in that half second here, I've tested 54 different things. So as I, basically as I develop against my my own automation, this is what makes sure that I am not breaking it as I'm developing on a new area. So is anyone here interested in behavior-driven testing, or is this something I could potentially skip over? So I've showed you the nose review. It can be plugged into a continuous integration system like Jenkins, where every time I commit, there's a post-receive hook or a post-commit hook that will kick off my build in Jenkins and run all my tests for me. So I don't have to do anything. I just commit to the repo, and the tests get run. So the next tool that we were going to talk about was Lettuce. And Lettuce is a behavior-driven development tool. Does anyone here do behavior-driven development?
Well, I use Lettuce.
You use Lettuce. Okay. Where are you getting your Gherkin features from?
Right. Well, so I'm writing them.
You are writing them. Okay.
But I can give it to a non-technical person and say, write them like this.
Right.
And I will translate. Even if it doesn't get the exact,
Okay.
regexes that I defined, then I can.
Is that working for you?
Well, it's in progress.
Okay. All right. I'm interested. I really am. Because, I've been trying to define what behavior-driven development is, and the best description I found was it's test-driven development via a common tool set with non-technical business analysts. It's really a way to write a test in English, but a very structured kind of English, which we refer to as Gherkin. So it's Python's version of Cucumber. You may have heard of Cucumber. It's really hot right now in the Ruby community for doing exactly this, and we install it with pip, of course.
No.
It's like
Yeah,
pizza
Gherkin's
is here.
a little pickle, right? So yeah, the way that Gherkin's defined on Wikipedia is a business-readable, domain-specific language. That doesn't make any sense to me, really. But yeah, essentially it's English. We'll take a look at it in a second.
That's what COBOL was supposed to be.
So every major feature in our system, we write what's called a feature doc for it. And the feature describes a distinct set of scenarios. And these things all are comprised for one Gherkin file. And here's a Gherkin file, right? This is a simple feature as well. It's a function that computes a factorial. But so on the top we have some documentation, right? This is actually not actually executed. Line 6 really is the title of the test, and lines 7 through 9 are actually the test. 7 through 9 is the test, and we have this a couple different times. Maybe if we were really clever, we might data drive this some way. But for this one, this is like essentially their tutorial for Lettuce, and they haven't done that. But let me show you the code that's behind it. It's kind of like Django's URL matching with the regexes. It's setup.py is the name of the file, and what you do is you define your steps. So it's always this given, when, then syntax. So you want to say, given I have the number input, I compute its factorial, I see the number expected. And you can look at the code here, and all we're really doing is just running it through this factorial function, which is right here. This would not be appropriate really for production code, but we want to have the function under test on this same screen here, just for readability. But yeah, this allows you to run it and have a nice output that makes a lot of sense after you go through these steps, which is what they like to call, I guess, the way you iterate through your testing. You run your tests, you watch them fail, then you write code that makes them pass, and then you keep going. So this is what your output looks like. So you can see, basically, if there was a failure, you would see the failure on, which exact line number failed of your scenarios. Now, whether or not Lettuce is particularly appropriate for you is up for debate. I can tell you, I haven't found a way to use it yet because I've been looking for. I think what really makes it powerful is the ability to interface with non-technical business people, requirements people, stuff like that. If we're not doing that, then it's really just test-driven development. And as engineers, we're writing the tests in Gherkin, even though maybe there's not a reason to. Maybe that's my personal opinion.
The problem with BDD, my experience with it, has been that I love the concept, but in practice, I've never found it to be, I try it, I start it, and then I wind up running it, going back to standard
Right.
techniques, primarily because if I was doing more of a formal definition process, I think it'd be great because then my requirements would drive both.
Right.
But the problem is there's a separation between requirements and testing.
Mm-hmm.
So BDD makes sense to me if the same set of specification drives requirements and testing.
Right.
But because they're normally separated, I've yet to see the value added when they separate the
I
process.
do have a friend who worked in an environment where his basically requirements people were writing in Gherkin.
Mm-hmm.
And that seems really powerful because they have basically what they're doing is they're writing the test.
Right.
They're writing the test, and it's your responsibility to write those steps that'll make those, parse those sentences and make it work. But if it's not a requirement, it wasn't a requirement. That's on them. So you got a little bit of a safety net. So whether or not it's appropriate for you, you'll have to figure out on your own.
It wouldn't work for my clients because they don't know what their system is supposed to do or what they want.
Right. Now there's a magic function in Python for that.
How do we know how to test it? We don't know what it's going to do.
Yeah. Why don't you build it and then we'll tell you what you did wrong.
Been there.
Yeah. Right. Yeah, I've been there too. All right, so nose and lettuce share a couple of common benefits, is that they both can be executed right from the source tree. Right? We didn't have to deploy our application to test it. We could just run it from code. There's thoughtless execution. We can automate this process. There's tons of automation, not just the continuous integration stuff that I was talking about earlier with Jenkins, but there are also tools that you could have that you could set up that will run your unit tests as you write to disk. So you've popped up a file, you've worked on it, and you've written it to disk. Your unit tests will get run in the background, and something will pop up telling you you've just broken something if you have. And I think that's what makes this really powerful, is that it shortens the feedback loop. And it saves the company money. Shortening the feedback loop will save the company money in the long run. And so I want to take a quick little second just to talk about this. So this is a diagram that was done by Jesse Noller, who wrote a blog a couple years ago called The Cost of Not Testing Software, that really kind of resonated with me. He created this ladder here. And he shows you that basically the developer focuses up here in the unit tests. The test engineer focuses on B through E. All these different phases of testing: smoke simulation, acceptance, stress and scale, performance. But then our users are also testers too. And really, QA and testing is a game, right? We've written a bug into the software. How quickly can we detect it? And the game is that the bug starts up here and it winds down this ladder here, and if we let it get to the bottom, we've lost the game. So the job is how quickly can we win? The quicker we detect a bug in our software, the less money it costs us. Because for instance, if we detect it here at the unit test level, the developer is still sitting at his desk. He has those methods are in his head still. He doesn't have to relearn his own code that he wrote a month ago and figure out what was wrong. He's sitting right there. And the same thing as it goes up the ladder here. Smoke simulation, these are very quick as well. We can prevent a load from being taken, received by the QA team and loading on all their servers before finding out that there was something simple that we'd screwed up, and we wasted an hour of everyone on the team's time. Well, that adds up, So the quicker we can catch a bug, the more money it'll save us. So Robot is an acceptance testing framework, and it's actually very versatile. You can do BDD in Robot because it's keyword driven. It runs on 3 major Python interpreters, of course, Python, but also Jython and the Iron Python. It's a .NET Python interpreter. It's open source. There's a large library of built-in keywords that come packaged with it. And there's a lot of community plugins. There's a Selenium plugin. I think, are you guys using the Selenium plugin?
Yes.
I recall it from a previous meetup. There's Phantom.js. It's called, what's it called? What's the plugin named? I can't recall.
Like Robot Phantom JS?
Yeah, Robot Phantom or something. There's a water plugin. And then, of course, some more standard stuff. SSH, HTTP, the requests library. If anyone's used the requests library, that's my favorite. And then someone mentioned on the list there's a VM run library, and I did poke around and saw that. I did see that. I'm not using that one. I do some VMware stuff totally unrelated to actual testing, just for our deployment stuff that I use a different library called PySphere for. It has some good community support.
PySphere, is it being maintained?
It is. It is. I can tell you that a lot of the features that are kind of being talked about on their wiki or their issue tracker, the maintainer really kind of makes the golden snippets almost, and then accepts pull requests. So I could see that the body of work is getting better, but it's really not included in the product itself. So let's talk about a quick Selenium example for Robot. How does a keyword-driven approach, and that's what makes Robot so powerful, is its keywords. How does it differ from a regular WebDriver script, right, where we would type a Python file, instantiate an instance of WebDriver, and run some tests against it? The reason that Robot is valuable is because you may have a method in your WebDriver script that says log in, and it includes a particular element ID, and you use it all over your tests because you got to log in the first thing you do for every test. Well, on the day that some developer decides the capitalization is wrong on this element ID, let me change that. Well, now you can't locate it anymore, and you have to update your tests. And if you've written them all by hand, you may have to update 100 or 1,000 tests hopefully you have some cool Perl Py command you can do, so you don't have to do it all by hand. But if not, you won't have to do it all with Robot. Robot, because you build a keyword that will say login, you can use it in one spot, and it's easier to maintain. It's easy to read keyword-driven frameworks, and it lowers the technical barrier. So we could create a scenario where our more technical members of the team are actually creating the keywords, and those keywords will be maybe Selenium stuff, Selenium low-level Python stuff, but maybe you have a less technical member of the team, a newer member, someone less, less technical, or an intern even, writing your actual test scripts with those keywords. And I'll show you how easy that is in a second. Robots, same thing. Pip installs pretty much everything. One thing you may want to do is pip search robot framework, because it will show you all the different libraries that are on PyPy for you to just pip install. Like for instance, this SSH one is on it. I had to do that for someone the other day. The one thing that you will have to do is, at least this is for Ubuntu, is install WXGTK. It's like their graphical library. And I was unable to do it really on my MacBook after spending maybe an hour or two looking at it. So there's some good links. This is a really good walkthrough on Robot if you have questions after this, and this is the actual site for Robot. So this is just a quick little high-level architecture, and you can see what Robot's really great at is separating that test data from the actual test code. So let's just start off with a really simple test case. User can create an account and log in. Okay, that's the title. The action is create a valid user, and it takes two arguments, Fred and password. This action here is actually a keyword, right? So there's another piece of code somewhere that is a function maybe that says create valid user, and it takes two arguments, and that's what it does. Keywords can be combined and used on top of each other, and I'll show you that in a second. But if you can see here, we've used the same keyword to run two different tests. We're creating a valid user up here, and attempting to log in. And these keywords are the same in both of these. The only difference is the status should be either logged in or access denied, because the input we've given we know is going to fail. So that test was really easy to write as long as these keywords were already written for us. We can data drive our tests. So we have one action, one keyword here, and we just give different inputs, right? So the titles are, too short and too long. Well, too short and too long produce this invalid length error message is what we're expecting. And the rest of them all are just, invalid content error message. But we're able to data drive it and write 6 tests with really one keyword and just a couple different inputs. So figuring out how to leverage your keywords properly is one of the, obstacles to doing Robot the right way. We can see here, we have this one's pretty simple. Let's talk about this one. Create a valid user, right? So we take two arguments, we define our arguments, and this is all in the original format, right? This is the TSV format. I'm going to show you the IDE in a second. It makes it much easier to do this, right? I started out with Robot doing it this way, and I didn't really care for Robot. But once the IDE came out, all of a sudden I really like it now. It's just much easier, much shinier. So we're using this, for instance, this one here, login, takes two arguments. Attempt to log in with credentials is a totally separate keyword that's not defined here, and so the status should be. But let me show you in a second the actual, some better keywords, because I wish that these ones were defined on this screen, but it's not. But you can use this in BDD, right? So we can use that same given, when, then syntax in Robot, as long as you do it, in this way, with no input, with no arguments. Okay, so let's see it run real quick, and then I want to talk about a couple things. Hopefully I don't get too bogged down in Robot, because we have one more module to go through. Whoops. Whoa. Some technical difficulties here. Okay, all right.
That's better.
Okay, so this is the Robot IDE. It's called Ride. You can see that I have mostly API tests right now. This is a top-level suite, those folders, and each one of these is a suite underneath of it. And you can have, suites of suites. These are what the test cases themselves look like. Actually, that's not the suite I wanted to open. This one, yeah. Okay, and so, for instance, if you wanted to quickly run this, you can run it right from the IDE if you want to. Am I hooked onto the internet? Why does this fail? Okay, I'm in. Let's see if it'll pick it up. Maybe not. Let's try it again. Okay.
That's better.
So I go through, and basically this is a particular resource in our web service interface. It's an asset in our system. And I go through and basically toggle every single attribute of that resource. Now we see that actually one of these tests failed. We had 23 passes, but I did have a single failure. I was actually anticipating that failure because we have a minor bug in the system, and it's already been ticketed, right? So I can tag these things in different ways. I've tagged this particular test as a defect and non-critical. I have a reference to it up in my documentation about what ID that particular ticket is. And because I've tagged it non-critical, I've told Robot that when you execute, don't fail the test, but don't fail the suite based on this test failing. We want to take our tickets and our bugs and put them into the bucket of things we know about. We only want to be alerted to things failures we're not anticipating. So this is what the report looks like for Robot, at least the stock one that comes standard with Robot. It gives you a big, this is actually green, it looks kind of washed out, but gives you a nice big green background. It'll turn red if anything has failed. Any critical tests that failed, it'll turn red, but we see that all critical tests have passed. We can do all this sorting. We can sort based on our tags. Like right now, all these are tagged API. But if I had API tests mixed in with UI functional tests, mixed in with, maybe like back-end Python tests, we could sort them based on just that.
Upper management would love a screen like this.
Oh yeah, that was it's definitely a big benefit. It's something free you get with Robot, and yeah, it's there for forever. So, I think I'm going to skip the Jenkins integration. I have Robot integrated with our Jenkins continuous integration server, so every time Steven or myself touch our automation suite, we add a new keyword or we add a new area of testing. Our continuous integration server is alerted. He checks out the new changes, and he actually runs the test against one of our servers that we know is going to be up and running the right, the software that we're expecting it to be running, so we can tell if we broke anything, right? So we have that same thing in our group that you may have on your development side, which is this green light, green light, green light, and then when it goes red, I can come grab Steven physically and say, you just broke this. So
it's not my fault.
Yeah. Let's take a look here.
I got a quick question here.
Sure.
It worked on my computer.
What's that? Oh.
Do you get a defect or bug in that? Do you get a bug? Can you assign to a developer to that robot ID?
No, you can't. No, you can't. I shouldn't say that. There's probably something really clever you could do, because it is very extendable, and you can have on failure kind of actions that you can hook into. If I recall correctly, we don't have that set up yet. That would be pretty cool.
I see an inefficiency here. All the developers that care about their reputation are going to be running the test before they commit stuff.
Right.
And then when they commit it, it's going to run the tests again. So all the tests are going to get run twice.
True, and that's actually good engineering, right? Because my job as a QA engineer is to not trust you when you say that you ran the test and they passed, right? That's why they pay me.
Or would the environment be slightly different?
Yeah, because they would run it on their machines, and it would pass on their machines. But then when they commit it, it would be running on the central machine, so that wouldn't necessarily pass if something was that much different.
Well, in that case, you would need a way of logging that they did in fact run the tests in their machine, and and got the pass, and that would be a clue that there's some difference in the environment.
Well, the developers are going to be expected to run the unit tests. Anything that can be run from the source tree, we would expect the developer to run. And we wouldn't just expect it, we would essentially demand it. What we would do is we would hook it up with a post-commit hook that we're going to run the tests when you commit, regardless of whether you want to or not, we're going to run them. Good.
One thing I think you might be alluding to, in certain contractual situations, there are cases where there's two sets of test suites that I've been with. There's a set of test suites the developers have access to and data they have access to. There's another one they're never allowed to see or know anything about.
Right.
Because the issue is whether or not someone could game tests. So
Right.
for contractual releases and acceptance and some
Yep.
government contracts have been in, that test suite is kept secure and kept away from
Yeah.
developers. But there's another test suite the developers can work with
Right.
and keep adding to it, with the idea being, they don't even tell them necessarily what fails in the other test suite. They just say, you failed in these kind of general things.
Right. Yeah, and in fact, I think for particular government projects, some of them, like, they're actually completely different companies. They'll have an independent company to do one set of tests than the other for those reasons.
That's where you're getting into, you know, if you
Well,
don't
in
trust
that
the
case-
if you don't trust the developer or the group, that's where you want that thing.
Well, in that case, it wouldn't be the same test suite.
Right.
So that would not be a waste of resources. But
Well, first of all, these are machines, right? These aren't people. Since we've automated this, you know, I mean, we can queue them up. You can queue up builds. You know, if 3 commits come at the same time, well, they're all queued up. You know, and overnight, maybe we catch back up. If there's really that much activity, you know, then great. And overnight we catch up. But yeah, they're computers. They're cheap, right? So we don't have to worry about it. It's more important to keep our software on the rails, so to speak.
When we're using Robot for one thing I found was really useful, which was generating test suites for the end users where we wanted them to do the computations because there's certain mathematical things to what
Mhm.
results do you expect in these situations.
Yeah.
And it works very well for setting that up, and using the keywords lets them kind of write test functions.
Right.
So they can
Yeah.
set up a scenario as a single keyword
Mhm.
rather than have
Yes.
to write unit tests. Overall, it seems roughly parallel to the power of a unit test. Though.
Can you execute it from the source tree?
We can't, but we have an issue with our source tree because it also requires us to have some external services running as well that we
Okay.
have to start up and set the
Yeah.
ports for and that kind of stuff.
Yeah.
The real, we're using RabbitMQ to do cross communication between layers.
Nice.
So unfortunately, you can't test in isolation those things because you need
Right.
the backends running. So
Yep. Yeah, and I've struggled with the same kind of issues. Is that, you know, you'd like to, you know, isolate this stuff, but sometimes you can't.
it's one of those things like there's a level of cheating. Like I know I should isolate every test, but there's a certain nicety to setting up a
Yeah.
scenario and doing 3 or 4 tests in
Right.
one scenario, even though
Right.
it's wrong.
You have to determine what's practical, right?
Yes.
Because if you can isolate every single test, you can mock every single interface. But when those interfaces change, you need to update the mock, and that becomes a maintenance overhead problem if you have so many mocks that you need to update when you change something critical. So yeah, you got to find that practical
So-
medium.
We really like that because it didn't require end users to understand the
Right.
the challenge of running unit tests, you know, running
Sure.
to get the nose.
Running tests, yeah.
But what we haven't been successful with is like we set up Selenium and
Mhm.
Robot for Selenium plugins and that kind of stuff, and it's just painful.
Yeah.
We have yet to find, and that's one of the things I was curious about that I hope we cover. I have yet to find any good way for web testing. You know, Selenium's close, but it still isn't there, and it still doesn't tell me between browser. It's
Yeah.
hard to write, and
Yeah.
things change. It's just hard to maintain. I'm trying to find a better user interface paradigm. I know theoretically what should work. Then then someone physically executing a script on a piece of paper.
Right. I think that you're going to be stuck with Selenium. I think that Selenium's the best out of a bunch of bad
It
tools.
doesn't test IE and Chrome very well.
That's what we use Lettuce for. So we use Splinter, which basically sits on top of Selenium.
Okay.
We use slightly higher abstraction, but it's a pretty thin layer. But that's what we use Lettuce for.
Okay.
So that's how we describe like the web testing, like, you know, given a user is logged in, when he clicks this button and he fills out this form, then he sees that. And I find that for us it's a pretty good abstraction level for describing interactions with the web.
So we do but how do you do cross-browser testing that?
So it depends. I mean, it's really using Selenium underneath, so we can test against Chrome. So we can basically do Chrome and Firefox testing.
But no IE or
Yeah, so we're not.
I mean, there are drivers for all this stuff, right? There's Selenium drivers for all those browsers, and there's even a Selenium driver for Phantom.js. It's called Ghost Driver.
Okay.
But the negative is that inevitably you get into a scenario where the drivers behave subtly different ways, and you end up having to do an if IE driver this, then, or if Chrome driver that, and that becomes, you know, like you've crossed a line when you've done that. You know, it becomes you have to judge whether or not that's appropriate for your, you know, your scenario, or maybe you're creating a maintenance problem for yourself. So, yep.
Quick question. So, this reporting thing can
Yeah.
be organized to a server.
Oh yeah.
And
So Jenkins, right? So besides this report, It'll also output a XML file for you. And I think it's called output XML, like by default. But that XML file can be read by, for instance, the Jenkins continuous integration server, right? So we can track how many tests are passing and failing in the CI server and plot that over time for each build. We can go into any individual build and pull up the report, of all of our test cases, and right, we're over 1,000 now. But we could pull up any particular build and determine what the status of that particular test is.
HTML report from the Jenkins?
You can. It saves. Not only does it create its own report essentially by reading that XML file, it stores all the source files. So even the original XML files there, the log files there, and this report are all built in. And maybe I'll just jump over there and show you real quick. But I wanted to make a quick point, which is that all these tests that I'm running, this is down in the log. I've just clicked on a particular test. They're all running one keyword. My keyword is update attribute should succeed. Right? So for all those 25 tests that I wrote to update every single attribute of that resource, they're really only using one keyword, which is this. And I just give it some input. What attribute, what the value is, and where I'm assigning it. And then these ones are all inherited from this. So on the day that updating one of these attributes changes, I update this keyword in one spot, and every single test in my entire suite that uses that keyword will be updated. And Robot's really nice about allowing you to drill down into this stuff. I mean, if something went wrong, or even if something went right, and you just want to take a look at it, you can pop this stuff open. This is all logging information that I've included, right? You can, in your Robot files, you can, from Robot API, import logger, and then use logger everywhere. Logger.debug, here you go. Here's my debug ones. Here's my info ones, logger.info. Here's a different one. And if it all becomes too much information to stare at, it's got this logging filter right here. So you can change it, and then now we only have our info messages. It's probably not enough information for this particular test. But on a test that has a whole lot of network communication, it's much easier to look at like that. So you get all this stuff for free with Robot, and it's really it's powerful for those reasons, I think. All right, so I'll try to do a quick. We'll do a quick one through multi-mechanized because I know it's getting a little later here. All right, so multi-mechanized has a couple dependencies: matplotlib and numpy. So multi-mechanized really is a scaling and performance testing tool. Essentially, what it does is you can build little programs that do some action in your system, and then through a configuration file, you can basically tell multi-mechanized how many users you want to be executing this set of actions, how many users this one. If there's ramp-up periods, you want these guys to start to ramp up slowly so you don't bang your system and you crush it, and how long you want to run the test for, stuff like that. So what's it give you for free? It gives you report generation, some good graphs in there. It aggregates statistics, so if you have 10 different things you're doing, you get some aggregation statistics there too. It's easily scalable. You can go from 10 simulated users to 100 simulated users trivially. And it's pure Python. So what's missing here from performance testing is instrumentation, right? So we have our one side, multi-mechanized, is the outside, right? It's a test tool. And it can give you, it can tell you how much information or how many actions it can do, how many transactions it can do per second. But you don't really know what the effect of that is on your system unless you provide the instrumentation, unless you're tracking what the CPU utilization is. How many MySQL inserts are we running at any given time? Stuff like that. Metrics that you care about, you need to provide as well. You need to have some way of collecting that as the test is going on. So it's just a pretty simple layout. You have like a little project for your multi-mechanized. One I'm going to show you is called example. A quick configuration file that basically says how to use these test scripts. This one gets 10 users, this one gets 20, stuff like that. So this is a simple script. One of the things I wanted to point out was that Mechanize has a built-in browser to it. So you don't have to use Selenium, or you don't have to use requests, anything like that. You can interface directly with the Mechanize browser. I know that they can. It's not too terrible to fill a form out to log in, stuff like that. So yeah, this is a simple test. All we do is we start a timer, we open a particular page, we read it back, read the body back in, and calculate the latency. Then here we initialize this custom timer because this is going to come in the report later. We're going to record this value into our EM7 test VM homepage report. And then I do a couple of certs down here to make sure that not only did I get a 200 OK, but there's something actually valuable in the response. It's not a 200 OK that has nothing inside it. There's actually, this down here, this get data actually will look into the body and tell you if the page looks the way you expect it will look. So the next thing we need to do is set up our configuration file. So we're going to say that this test is going to run for 30 seconds. We're going to start right away. There's no input period. And the test results, the interval we're looking for are like, our percentile calculations, median, mean information is 5 seconds is an interval. This is some good stuff for I guess debug logging, progress bar will show you how far you are on the command line. Console logging will provide you a lot of information if you turn it on, debug stuff. And the XML report will basically spit out an XML formatted report that maybe could be integrated into Jenkins, which actually we are doing here. So yeah, we can hook that into our continuous integration server as well. We can set thresholds. We can say this amount of errors is acceptable before the build becomes unstable, and this higher amount or less of amount is acceptable before, or else we fail the build. We can fail the build based on these results as well. So right now we have this simple example that I just showed you set up to run in 3 threads, and we're going to call it user group 1. And there's the second one here that's commented out right now. It's not running, but later on we're going to run that one too. So how do we run it? Multi-mech run, and then the name of that project. And as I mentioned, this project is named examples. And we can see that it did 1,532 transactions and had 0 errors. And taking a look at the session setup here, this one is okay. So this is a similar example. It's actually a little bit more complicated. The distinction I wanted to make with this example is that there's sometimes we want to do something once at the beginning of our test, like a test setup. Log in, right? We want to log into our system and then access maybe a restricted page multiple times. We want to do stress testing on that, but we don't want to log in every time. The login's not part of the test. It's this page is the test. So what we do is in the init method, what I use the request library. That's my favorite way of doing HTTP stuff. I create a session that I then, I open the session to our server and I log in, I authenticate. And then I open a particular page. This is the ticket management page, which has database access, pulls a bunch of tickets out of our system and shows them and displays them to the user. And I'm going to call it EM7 tickets for our reporting. I do the similar checks I did in the other one. So when we run this, did I not include that slide? Okay, let me actually execute it then. I got it right here. Whoops. Not this again. Okay. So I'm actually going to run through and execute this right now. While this is running, actually, I remember what I was going to show you, which is the actual Jenkins results. And hopefully they're still in there. Been having some problems with Jenkins in this project in particular. So we have our 3 projects here. The robot continuous integration is the one that I showed you earlier, and you can see that I have these little statistics here. There's a little robot guy. Got the integration going. In the performance testing project, I just created this morning. And I've actually lost some information. You can see that some of these builds are missing. I don't know why or where they went out to look into it. But they show you this kind of stuff, right? It'll show you over time, the performance of your system is getting better or getting worse. And, especially in a system where, there may be a lot of unknowns, performance testing is a good way to look at all of your software in the system and as an aggregate, right? So you may not be able to tell what broke or what got better, but you can at least tell that it's happening. Right? So if you see a spike in your performance metrics, you want to know that before you release the software so you can find out what's wrong. So that is everything I have. We're actually right on time. Sorry if I sped through some of those sections. If you have any questions, I'd be happy to answer them. Go ahead.
Do you have Jenkins configured as part of the CI process to run it every time, or daily, or how are you hooking up multiple?
Okay, so the performance metrics I have set up. I literally was like, I should do this morning. I was like, I should do this for the demo tonight. I have it, it's just a static build. There's no integration. I just go click build and it runs the tests. But the way you would normally do that is that you would include a commit hook, right? So I don't use SVN or Git.
Both.
Both. Okay.
I wish I could. I wish I
From
could
your
lock to
career,
one.
Yeah.
There is never going to happen that way.
So in SVN, it's post commit hook, right? In Git, it's post receive hook,
Right.
because you have to push. But when these things happen, it's really trivial. It's like it's a simple web call in the hooks directory that says send this request off. That like basically notifies my server that says, hey, somebody just committed, and then the Jenkins server checks the code out and executes its build, whatever you tell it its build is. And that build could be compiling code, or that build could be just execute the unit tests. You know, and you can chain all these actions together, and I can show you real quickly here if you.
But you have it chained into the for Jenkins, though you chain it to all builds, or do you select builds? The performance one.
For the performance one, I'm not doing anything. The performance one, literally, the only reason it's in here is because two reasons. One, I actually did the performance test against our product. I said, if I'm going to authenticate with a website and run some performance tests, I might as well do it against my own product. A, and B, and I figured it would be good to get it going in Jenkins, get the project going, but I haven't had a lot of time to really devote to doing it like the right way, more than just for like a demonstration purpose for right now. The robot one is more hooked in the way we would want to hook it into for an actual real continuous integration environment. So you can see what I do here is I have source code management with Git. This actually it's on my local system, right? So this normally would be like a URL to your GitHub account or wherever your Git repository is, but it happens to be on the same server. Which branches you want to build, and there's different things you can do here, and how you want to do it, right? And so basically he gets notified and then he pulls. And then I'm doing just two things. This really is the heart of my continuous integration. I set my path on this in the command, and then I run nose tests, but I just do it with XUnit. And that with XUnit is what allows me to generate an XML output file that Jenkins can understand. And down here, this is my entire set of robot tests. I actually do have a test executor machinery up top, and the reason I do that actually is because what robot doesn't have built in is data-driven suites. You can data drive a keyword all day long, but you can't data drive a suite. And I need to do that. I need to run this exact suite in JSON, and then I need to do the same thing in XML. And the only way to do that is to do it up top. Basically, build a wrapper method around it where you run the robot method directly, PyBot, or maybe it's robot run. I can't remember what the method name is. But anyway, in here is where I actually do all that, where I determine which tests to run, how to tag them potentially, and execute them individually. All these tests are individually executed. So I do have a problem there, which is that now I have not one report but 25. And so what do? There's a nice robot module called Rebot that will collect all these reports for you and collect them into one massive report. And if you were so inclined, there's even a plugin for robot called MABot, M-A-Bot, which is for manual testers. So if you really were like on the robot train, you could write tests in robot and say manual tester is going to run this, and they click a button that says pass, and they generate a report. And you can aggregate this all together with robot's built-in reporting tool. But yeah, this is where I run my tests, and this is bmanix test is the name of my VM under test really. And that's it. That was all it took. And then down here I had to configure the plugin. You know, publish robot framework results. What was the directory and what are my thresholds? There's really nothing. There's no magic built in. And it doesn't take long to set up. Jenkins is really easy. It's a WAR file that they distribute, so it's really easy to just drop in. You know, it took me maybe like an hour to set it up the first day I did it when I set it up.
And the published robot framework, is it part of the
This is a
robot
plugin.
plugin?
It's a plugin for Jenkins, yeah. And installing plugins in Jenkins is really, really easy. You know, you go up to Jenkins, manage Jenkins, or is it plugins? Manage plugins, and then it provides you a list. You know, you say you want to see what's out there. You know, you can just start searching on stuff. You know, and it will, and they're all available. It'll tell you if there's updates for your plugins. Be careful when you update. I'll tell you that I updated the other day without thinking about it. The Git plugin, and all of a sudden, any workspace that I created that had a space in the name had a problem. So I had to go through and change all my projects to have an underscore instead of the space. So yeah, but you can roll back even. I had done it in a way, I won't get into it, but I did it in a way that I could not downgrade. So if you do actually encounter an issue, normally if you've done it the right way, not the way that I did it, you'll be able to roll back to something that works. Yeah, so these are the ones that we're using.
Also going back to multi-mechanize,
Yeah.
Is there a way to monitor the server-side metrics like CPU and
Exactly. That was what I was saying. That like at the bottom, if you look at the slide, it's like that's what you need to provide, right? That's instrumentation, right? And it could be instrumentation about the server itself, or it even could be instrumentation that's built into your code, right? Like to get from to run this section of code took this amount of time, right? And you could hook that up there's different ways of doing that too. It's a whole other talk with stats D and graphite and cool stuff like that. You could visualize your system, your side, right? This is what multi-mechanized gives you, is the visualization of a user of your system, of something external to your system utilizing it. How much can I get out of it? But to really see the internal guts of your own system, you need to provide that instrumentation.
And in multi-mechanized panel, is there a way to control there is a way to control the console logging, but does it allow us to log for the test that only failed or something like that? Like, do we have control for a particular set of tests?
A particular, they only fail. Well, basically any transaction could fail, right? If any of the assertions that you're going to go through at the bottom of your test fail, then that test is marked as an error. How much debug you're going to get out of that is going to be related to what you're doing in the test itself, right? Because do you want to actually log as you're running? Maybe you want to have that as an option, right? You want to turn logging on and run the test, and you want to have the ability to turn it off, because logging takes time, right? We got to write to a file, and doing a stress and system performance test. Do we really want to do that every single test? Maybe, if we're having a problem, but maybe we don't. Maybe we want to let it just run as fast as it can. So that would be something that you would have to be responsible for. I can tell you that multi-mechanized will, that output, I think it was like XML output I turned on, it dumps out a JUnit compatible file. So that's what, I have a plugin that's, where is it? Is it this one? I don't think it was that one. There's a different one, a JUnit plugin that can understand those results and then track it, to do the same kind of tracking that we're doing on our robot project over in multi-mechanized as well. So you can see how many errors you're encountering essentially, and then you can look at these aggregate graphs.
And when we, in one of the code that you're written, it says mechanized browser. This browser is, are we forcing it to use a particular browser there? Or
I just wanted to show you that because I thought it was kind of cool. That mechanized, basically, as part of like the machinery of mechanized itself, they provide you like a browser class that you can instantiate a browser right in their software. So you don't need to bring in Selenium, or you don't need to bring in the requests library or URLib2. You can do all that if you want to, because it's pure Python. You can do whatever you wanted to do. You could have a function that I don't know, shot a missile into space. Like, it doesn't matter. But they do provide that browser just built in for you, and it actually does a pretty decent job of interacting with forms, which can be, at least in requests, it's not the simplest thing in the world. You have to jump through one particular hoop to get around an issue, but you don't have to do that with mechanized.
I didn't think their browser, I used it a long time ago that when I was having some problems with it. I don't think it supports JavaScript or anything else singular.
No.
It's purely
Yeah,
doing the
unfortunately,
URL, so
yeah.
it's not.
Right.
It
How
depends what
useful
you're
it is,
trying to
yeah.
measure.
Yeah, it may not be useful for you, and that's why I showed you, and the second example was the request library. That's the one I normally would use, not for browser per se testing, but just web testing. But I thought it was,
cool.
but you know what, it's just cool, yeah, it's just cool that the guy would give that to you, the ability to log into a form and then bang away on some resource that you need to be authenticated to hit. So it's probably not really appropriate for like a mature suite, but for just getting something going, quick and dirty, it seems pretty usable at least. It's cool. I thought it was cool.
Yeah, but it looks like with multi-mechanized, we have to, in order to view the transaction, the trend of transaction response
Mhm.
time, you have to wait until the test completes and it aggregates everything and
Yes.
displays it, right?
Yes. Well, I mean, you'll be able to tell. Yeah, to get the statistics you're looking for. Yes, you have to wait till it's complete.
I mean, in
You
other
can see
words-
what errors are popping. If you have an hour-long test, you can see how many errors are coming up as you're going through. But I think to look at the statistics, you're going to need to wait till the end. It writes to a CSV file,
Okay.
which you may be able to read as it's writing to it, but I don't know.
Yeah, I mean, in other words, it won't provide us the real-time
Right.
feedback of,
Right.
Like
Correct.
It says, oh, your transaction,
Mhm.
we
Yep.
may eyeball the rolling logs and say, oh,
Yeah.
the transaction number is increasing.
Yeah.
no problem.
See, that is something you would probably want to get from your instrumentation as well. Multi-mechanized is good as like a profiling thing. It's like we want to run this profile against a known system under test, and we want to do it in the same way before we release every time, right? So we have an A to B comparison really, But for the stuff that you're talking about, like a real-time stuff, there's really different tools.
You can
Tool sets for
export
that.
to graphite while you're running it or something like that.
That would be cool, right? In fact, you could do that, right?
Right.
You
You
could
can
do
use
that. You
that
do like
just
some
to
stats D
highlight.
stuff while you're doing your testing,
Right.
But you're doing something while you're doing your performance testing too. So you have to understand how that's going to impact it. Right now, you're sending a web call maybe in the middle of a performance test, and does that invalidate your test? I don't know. You tell me. So.
how does a robot framework work with Java, which has worked with Python, right?
I've never heard of Java, you said?
Yeah.
As you showed Jenkins.
Yeah, no, that was really more of like PR, for it than it was like, let me show you how to do it. I've only used Python like a couple times in my career, and it was, painful, and I wake up at night and think about it. It was still horrible. So, no, I don't know. You have to figure that one out. I'm not sure. I can't tell you.
And the VM run library?
Yeah. So yeah, installing these libraries is pretty simple. The VM run library, I was hoping it was going to be in the PyPy package index, but it's not, because then you can just pip install it. So what you're going to need to do is you're going to need to go figure out what you need to do is clone the repo into somewhere that's in your Python path or your namespace. So you can basically, if you jump into the interpreter, you can import VM run library. If that works, then you can use it in Robot. And I can show you real quick here if I still have the IDE up. Yes. When you import a library, so right here I'm importing two things. I'm importing a resource file. This is actually comment.txt. This is full of a bunch of keywords that I use everywhere. So I want this, have access to this. This is a real Python library. This is actually one that I wrote myself called Database Tools. This is how you would import it. You would basically go over, you click on library, and you can just add the name. It probably won't need any arguments because it's a built-in, not a built-in, but an add-on, right? Add-ons they're kind of written in a different way, to make them more extendable. My stuff's all very specific to EM7. But yeah, you would do this, and basically if this goes red, that's when you know that it's got an import problem. If it's black, it's good. And you can take a look up here up top at the ride log. And there's nothing in mine because it had no problems. But this is where you would see the information. If it had problems importing, it would say, hey, I expected 2 arguments and got 1, or or I don't see this module at all. I don't know what it is, meaning maybe it's not in your path, stuff like that.
Go ahead.
I wanted to know, you're using this robo framework and the resource libraries. I believe multiple people using resource libraries and using the keywords,
Right.
whatever keywords are there. So I just wanted to know how you guys are managing the versioning when multiple people are working on multiple keywords, because it's a normal text file on a robo and creating the keywords.
That's right.
So how are you guys, I don't know if you guys have this problem of versioning it.
I can tell you, I heard about your problem, but we don't have that problem yet. There's only 2 people writing keywords right now, soon to be 3. So it's a manageable problem at this point. And to be honest, most of our suite is it's really dedicated towards the web service. And in that way, how many things do you need to do for a web service, right? We have more complicated keywords, higher level keywords that we're going to build for sure. But a lot of it is, building a payload and sending it off and seeing what comes back and, making assertions based on it. So we don't really have a huge library yet. We're getting our functional UI library going right now, and that'll probably have a significantly higher number of keywords. But what we normally do is that, and I might have a good example here of any particular area. All right, so this API custom field test. See, I do have one keyword here. What we do is we try to leave the keywords in the suites that they're used in until the time comes when we want to use them in a different suite. And at that moment, that's when we want to put them in a different kind of resource file somewhere. Right? And we only have one right now. We're calling it common. But there's no reason we can't break that out into anything ticketing related, or anything account related, and then import that into any given suite based on the need to use a keyword.
Because those other libraries also have keywords in them as well, too.
Right. Yeah. You can build keywords on top of keywords, and that's really what makes it powerful. Is because you only want to write the code one time in one spot, and that's why you don't have to maintain it in one spot.
Yeah, and then when you have the common keywords, it's used by somebody in a test. So if I'm using somebody's keyword, and for my test, I believe there is something missing in this particular keyword. I want to add something to it. Now I have to do an impact analysis. Okay, this keyword has been used in 5 different suits.
Yeah,
okay,
and you can do that. You can do that through RIDE,
how many
right?
tests are
You've done that, right? You know how to do that. Yeah, you can see where the keywords are used. You can find a keyword, say, show me all the places this keyword's used, and it'll list them out for you. You can quickly navigate to them, as well as unused keywords. Show me which keywords aren't used anywhere. We should delete them. But I would say the way to solve your problem, or one of the ways that we're really going to solve it, is through continuous integration, right? We have one VM that's always in this one state that we know about, so anytime we change something, it executes the whole suite again. And it better pass, because if it doesn't, then either I'm going to be, if it was me, then I'm going to have to fix it and say, what did I do? I'm right there, I'm still in that same mindset, I have quick feedback, and if it was Steven, then I can go find Steven, or hopefully he's been watching the results if it passed. So, it gives you that instant feedback that at least if you find out, maybe you broke something, but you broke it 10 minutes ago and you're still ready to fix it,
Isn't that just a matter of understanding these keywords just like any other API or function that have to be controlled, and that, you know, they themselves are specs like that? And
Right.
It's the same as changing a DLL or anything else.
Exactly.
And you should look at them as dividing the, like, we layered even for our simple stuff like libraries.
Mm-hmm.
The only issue was
Like a tree of keywords, essentially.
well, common, and then
Yeah.
then this product specific one a little
Right.
bit. Again, very small stuff we were doing.
Mhm.
But just because I didn't want my users doing their stuff, having to even see this stuff, just know about
Yep.
them. But there was something I was looking at in terms of like naming conventions, because
Mhm.
you've got a lot to do with the global namespace, you know, and making, you know, the namespace issue becomes a little bit of a question.
Yeah, the namespace issue, like the namespaces are their scope is to the suite that they're being executed in. So I can have this keyword create custom keyword, which is a totally different keyword in this suite versus this suite versus this suite. As long as when it's used in this suite, it knows that it's going to use the one for that particular suite. And it's,
Right.
once you put it in a common resource file, then it does become another management issue, a tracking issue, making sure that all your suites are going to use it the same way.
I have a question for you. Virtual E&D.
Mm-hmm. Love it.
Okay, how does
Yeah.
it fit into your automation suite, and how do you use it?
You know,
I cheat. I know I should do it, but I don't the way I should.
right. I get out of really doing it by saying I'm just a test guy. I don't work on production code. You know, the production guy should be doing that. No, but no, I do. We do have virtual ENVs. It's a really great way to sandbox. If you guys don't know about this, it's a great way to kind of sandbox yourself in a Python environment. You can have different Python versions. You know, that maybe you want to run some Python 3 stuff, but you don't want to update your, you know, Mac OS, you know, Python 2.4.